I'm Anil Kumar. Welcome to our website on Global Math Institute. The idea here is to make videos in easy English language which can be understood worldwide. We have taken up two examples based on inequalities in this particular video. We'll see how to sketch a graph of inequality. So the two questions here are: sketch graph to satisfy each of the following inequalities. In the first question, we need to shade the area which represent the set of points that satisfy the inequality. 6 examples have been taken here. The second question, we need to sketch graph to satisfy each of the following inequalities. However, this time, leave unshaded the area which represent the set of points that satisfy the inequality. And we have taken 3 examples here. It is very important to understand what to shade, and that is why that is highlighted in this particular example. So let us say that we'll just answer these questions on a separate page, but first let's understand this. Shade the area which represent set of points that satisfy the inequality. It means what? It means that if I have a graph, and let us say we are considering linear functions. Let's say this is my line, which is some equation. Let's say y equals to, let's say half of x plus 1, right? Now, if the question is that we need to sketch the area where this particular line shade the area which represents set of points that satisfy the inequality. So if I say that half of x plus 1 is greater than, let us say, y, where this is the line, right? Now in that case, what are we looking into? We are looking into the area because this line represents that it is all equal. And here we want that y is less than the given value, correct? And the question is to shade the area to represent solution. In that case, tell me, what are you going to shade? Now, since y is less than this value, what we need to shade here is the area moving downwards. You may draw arrows also, right? But that's the area where we are saying that y is less than half of x plus 1. We have shaded the area which represents the solution, right? Now let's take another example, relatively simple example this time. So let us say we have a horizontal line which is, let's say, y equals to 5. And we are looking into the solution of inequality, which is y is greater than 5. And what we need to shade here is we have to leave unshaded area which represents set of points that satisfy the inequality. So in this case, the condition is leave unshaded area to represent the solution. That means shaded area is not your solution, right? Unshaded area is your solution. Then what are you going to shade? Well, the solution is upper half above the line, right? So what you are going to shade here is this area. So it says leave unshaded area. We left that area on the top, leave unshaded area, to represent the solution. Y is greater than 5. Do you understand? That is important. Now here, note one more thing, and that is, since we are talking about greater than, the line is not included, right? And therefore, it is a good idea to draw a dotted line, not a solid line. Does it make sense to you? So this is mainly because we are talking about greater than, and in this case also, we are not including equal to, so we should be drawing this line, and if you want, you can draw arrows on both the sides. So I hope with this, the concepts are clear. By default, we are taking x along the horizontal axis, y along the vertical axis. That being the origin. Is that clear to you? Now, whenever you provide a solution, you can have a checkpoint, right? So which we refer to as a zero check. What is zero check? In this particular case, 0, the origin, is in the solution, right? So if I put 0 here for x and y, we get y1 is greater than 0, which is true, right? So that is correct. In this case, if I put 0 here for y, 0 is greater than 5 is not correct, perfect, and that is why we have shaded this portion. Does make sense to you? Sometimes we also say, instead of zero check, we say origin check. Basically, we are trying to figure out whether origin is in the subset of our solution or not. So I hope this is a broad concept and that is absolutely clear. Now, I would like you to pause the video and take these 9 questions as a worksheet exercise. So copy these questions, solve them out, and then look into my solutions. Correct? Now let's go through these solutions one by one. The very first one, once again, we're looking into sketching a graph to satisfy each of the following inequalities. We have taken the first 3 here now. We need to shade the area which represents the set of points that satisfy the inequality, right? That is what we need to shade. So the first one here is that x is greater than 3. Note that it is not equal to, it is greater than 3. The x value is greater than 3. That means x is on the right side of 3. So we'll draw a vertical line and that should be a dotted line. Is that clear to you? As explained earlier. Right? And we need to shade the area which is part of our solution. So this is not a bad idea, right? Drawing arrows. So in your test, that should be your solution. And it should be labeled. So you have to write 0. That is the point 3. This is x-axis and that is y-axis. This line here is x equals to 3. Does make sense to you? So that is how you need to provide complete solution. Is that clear? Now, let's move on and take the next one. X is between the 2 values, which is 1 and 6. Both are included, right? Both are included. So once again, that's our coordinate plane. Origin, x-axis, y-axis. Now x is between these 2 lines and both are included. So we'll have a solid line running through vertical, x equals to 1, and the other one, x equals to 6. And the region which is shaded is in between the 2. Right? So that is what is shaded. And this is part of our solution. You can see that 0 is not within our solution. So 0 or the origin check satisfies. If I write 0 here, 0 is not greater than 1. That is not a part of our solution and that is not shaded. Does make sense to you? Correct? So in these two cases, directly, we could plot the solution. Now let's take the next example, which is tricky. X plus 1 is greater than or equal to 2 and less than or equal to 6. Now, we can simplify this. We can take away 1 from both the sides. So we have 2 minus 1, and here we have y plus 1 minus 1 and 6 minus 1. So we took away 1 from all the three parts of this equation. So what we get here is that 1 is less than or equal to y, which is less than or equal to 5. So that's what you get. And now we can actually shade this solution. So the value of y is somewhere in between 1 and 5, and both are included. So we'll draw a solid line representing y equals to 5 and another solid line representing y equals to 1. Since y is in between these two, we are going to shade this portion. Solid line means that we have taken care of equal to. It is good practice to always label. So we'll write x-axis 0, y-axis, this is y equals to 5, and that is y equals to 1. Is that clear to you? So I hope it is absolutely clear. With this, let us move forward and take the next three inequalities. I'd like you to pause the video at this stage, sketch the graph to represent the solution, and you need to shade the solution. Perfect. Also, check whether 0 or the origin is within your solution or not. Alright, so we'll take a break here and then continue after a small break in which I'll show you a glimpse of Canada. We recently had a very beautiful snowfall. I hope you enjoyed the clip on snowfall in Canada. It's the month of December, 3rd of December today, 2019. We need to now sketch graph to satisfy each of the following inequalities. Shade the area which represent the set of points that satisfy the inequality. So the very first one here is y is greater than x. So what we can do here is draw a line which is y equals to x. Now since it is greater than, that means the line is not included in the part of our solution. And therefore, the line should be a dotted line, correct? So this is y equals to x. We need to now shade the area where y is greater than x. That means above this line, right? So that becomes the part of our solution. Is that clear to you? Perfect. The next one here is x plus y is less than or equal to 6. So one way is that we can just first sketch the line, and we know it is a solid line, right? Since less than or equal to 6 is there, to sketch this line, what can we do? Let's do some calculations. We have x plus y is less than or equal to 6. So it is a good practice to use x and y intercepts. and y-intercept to sketch the line. The x-intercept in this case will be 0 and 6. The y-intercept will be, x-intercept will be 6 and 0, and the y-intercept will be 0 and 6, correct? We have a solid line going like this, where the x and y intercepts, as mentioned, are both 6. Now, you need to decide which region should be shaded. Easy way is to do zero check, origin, right? So, if I write 0 here and 0 here, we know that 6 is greater than 0, and therefore 0 is a part of solution. And so the best thing to shade is to shade this region itself. Do you see that? So if you are in a doubt, this origin check helps. So how simple it becomes. Do you see that part? Zero check helps us to sketch very easily. We'll do it once again, right, with the next example. The next example here is x minus y is greater than 8. Well, I can rearrange this, right? Or we'll use intercept as we did here. Okay. So let's use intercepts. I think that's easier, right? So again, we'll first sketch a line, and this time the line should be dotted line, not solid. The x and y intercepts are what? X-intercept when y is 0 is at 8. And the y-intercept when x is 0 is at minus 8, right? And therefore, the line, which is going to be a dotted line, will be going through y-intercept of minus 8 and x-intercept of plus 8. That becomes our line. And now we are going to check origin. If I write 0 minus 0, is it greater than 8? False. 0 is not greater than 8. And therefore, 0 is not part of our solution. We are going to shade it in a direction where origin is not there. Do you see that part? So I think that is the strategy which can always help you to get the right result with least calculations. That is very important to understand. We have to do least calculations to get our result. Save time in any competitive exam. Does make sense to you? Correct? So in the first part of the video, we have shaded the portion which is shown as the solution. However, the questions are tricky. At times in the test, you may have something like this. Now here, note, it says sketch graph to satisfy each of the following inequalities, but it writes leave unshaded the area which represent the set of points that satisfy the inequality. That means you do not have to shade the solution, but the other half. Do you understand? That's tricky, right? So let's try to do these examples and figure it out. As usual, what I will do here is I will make my coordinate plane. This time I'll make all the 3 coordinate planes first. Okay. Now we have the equation 2x plus y greater than 0. Let's find the x-intercept, right? So x-intercept is, when I substitute 0 for y, I get 0. So the x-intercept is 0 itself. And if I substitute y equals to 0, I again get 0. So that doesn't really help. You get the idea. So the x and y intercepts do not always help, especially if the line is going through the origin. You get the idea, right? We need some other point also. We're sure that the line passes through the origin. Now how do I get the next point? Just assume some value of x and figure out what y is. That is one way. The second way is that you could rewrite this as y is greater than minus 2x. So rearranging could always be a good option, right? Definitely, we have a slope of minus 2. In this case, line is falling down. As you move from left to right, it is decreasing. Let's take a value of x as 1. So we'll now figure out a point. So we'll now look for a point. So if I write x as 1, y is minus 2. So we get 2 points. With these 2 points, we can always sketch a line. So if I take x value as 1, y is minus 2, I get this value, right? This is 1, this is minus 2. Joining the origin with this and a dotted line gives us our graph for the line. Does it make sense to you? Right? So one part we have done. That is, we have our line. Now, we have to decide which region to shade. Line is going through the origin, right? And we know that is not the part of the solution. Which side to shade? That's very critical. So that makes this question very special. Okay. So what we have here is y is greater than minus 2. So whenever you have a situation like this, think about something arranged in slope and intercept form. Now I'm saying y is greater than, that means y is above, right? So we have to shade the portion which is greater than. Means above the line, right? So that becomes the shaded portion. However, we have made a mistake. The mistake is because it says leave unshaded the area which represents the set of points that satisfy the inequality, right? So that is a mistake which you could make, and therefore this solution is wrong, right? You get the idea? So you have to be really very careful while providing solution, and the emphasis here is on this particular statement, which says leave unshaded the area which represents the set of points that satisfies the inequality. So strictly speaking, my sketch should have been like what? So let me redo it, right? In a smaller space. I have already explained you the concept, right? So write the equation in slope and intercept form. Sketch the line, which is a dotted line. Since it is going through the origin, you cannot do the origin test. And we want y to be greater than, that means above the line. But we need to shade the region which is not the solution, right? So we have to shade this portion. Does it make sense to you? On purpose, I've done all this so that you remember that you don't make this mistake in your test. You get the idea? It is kind of very important. Right? So, I'd like you to now pause the video and answer the other two questions. Remember, you have to shade the other half. Leave the portion which is solution as blank. Don't shade that, okay? Right. Next question is, y over x is greater than equal to half. It is a good idea to write what y is. Y is greater than equal to half of x, right? That is a slope of line positive half, and it is also going through the origin, this time a solid line. Since greater than equal to is there, and we are looking for a solution where y is greater than, what are we going to shade? We are going to shade the portion which is not the part of solution. Does it make sense to you now? So that is how you have to do these questions. Clear? Very important, right? The last question here is similar to what we had earlier. So we'll take away 1. So we can write this as minus 3 is less than equal to y, and which is less than, take away 1 from 5. So it becomes 4. So we're looking for the value of y, which is in between minus 3 and 4. So let's draw this. Since both are included, let us say this is minus 3 for us, and that is 4. We have to shade the region which is not part of our solution. So we will shade this portion. Does it make sense to you? So I hope you find this very interesting and useful. This is a very important exercise, and just this language, shading which portion, makes huge difference. And that's the reason why I've taken these examples and I've tried to explain you the concept. I hope you find it interesting and useful. Feel free to write your comment, share your views, and if you really like and subscribe to my videos, that'd be great. Thanks for your time and all the best.